Okay, episode 4 solutions. Yeah. So I imported the math module. We'll use it later in many problems. Tier 1 is the warm-ups, which is just did you get the syntax and understand the basics of the lecture. So augmented assignment, that means like minus equals, times equals, plus equals, divide, all that. Instead of saying x equals x minus 17, you can just say minus equals. Yeah, so nothing deep there. It's just syntax. So this says use augmented assignment, start with x equals 100, subtract 17, multiply it by 3, divide by 2 in 3 separate lines. So I did that. Comes out to 124.5. Problem didn't ask for it, but just for fun, can we do that as a one-liner? So subtract 17, take that quantity times 3, divide that by 2, get the same answer. If you forget the parentheses, it will not come out the same. This says x minus whatever 17 times 3 divided by 2 is. So you're subtracting 17 times 3 divided by 2 as opposed to subtracting first and then doing the operations of multiplication and division. So that's the order of operations again. Problem 2, the math module. Using math module, compute the hypotenuse of a right triangle with legs 3 and 4. You could do this with a formula, but it's built into the math module. So have you, the point was to have you poke around the math module. There's a link there. This is one of the modules from the standard library that come with Python. It's not all built into the language because you might not need all of this stuff, and there's like 200 modules or so in the standard library, and to load all of that it's just too much. So anyway, mathematical functions, it does what you think. It has number theoretic functions, floating point, etc. Lots of constants too, so you don't have to cough up pi or e or whatever to a bunch of decimal places. So what we are interested in is the hypotenuse. So I bet if I look for that, I can find it. Yep. So hypotenuse of coordinates, Euclidean norm of an iterable of coordinates. So you feed it a tuple or a list, and it sends you back the hypotenuse. If I click on that, returns the so-called Euclidean norm as the square root of the sum of the squares. Yeah, and that'll give you the hypotenuse. There's some more technical details, but that's the idea. So I say A is 3, B is 4, call math hypot on AB, print it out, and you get 5. 3 squared plus 4 squared is 9 plus 16 is 25. Square root of that is 5. Floor versus int. So what's the difference between math floor and integer? So try both and explain. So I take the floor, print it out, take the integer, print it out. The floor is always going to give you the integer below. And then if you cast a float to an integer, it's going to round it. So if I start with a negative number, the floor of negative 3.2 is the integer one below that. So that's negative 4. Whereas the integer of negative 3.2 rounds to negative 3. Using help, you can use help on math.log. You can use it on any function. And then some questions about it. So we do the help. Math.log tells you what's called the doc string. So it's help on the built-in function log and module math. Log has some arguments. What are they? You have the number, and then you have the base. The base by default is E, so it's the natural log. This is in brackets in this context. That means that this argument is optional. If you leave it off, it's going to fill it in with E, and you get the natural log. So the second argument is the base. It's all about the base. Problem 5, compare collections. You have some information about math course. Store each piece of information in most appropriate collection, type, list, tuple, decker, set, and explain why you chose each one. Okay. So the course covers topics, algebra, geometry, calculus, statistics. I'm going to use this as a set. There's no particular order to it. I don't care about order. It's either in there or it's not. So a set would be inappropriate. Structure, course info. The instructor's name is, the course number is, the enrollment is some number. So that's a block of information about the course. So I would use that as a dictionary with the different fields: instructor, course number, enrollment. Enrolled student IDs. 1042, 1087, 1091, 1042 again, 1103. So assuming you want to keep duplicates, you would store this as a list that preserves the order. It also keeps the duplicates. If you don't care about the duplicates, I suppose you could use a set. And if you want to make sure that these enrolled student IDs do not change, you could use a tuple, but people add and drop classes, so more likely a list would be the appropriate. The course days, the days the course meets are Monday, Wednesday, Friday, never changes. So use a tuple for that to keep it immutable so it doesn't accidentally change during the course program. Augmented assignment again without using exponentiation. Compute 2 to the 10th using only augmented assignment and starting value of 1. Actually use starting value of 2. Oops. And then you just keep multiplying by 2. Yeah, and then you run it. And what do we get? First it's 1, then we multiply by 2. We get 2, then 4, then 8, and 16, 32, 64, 128, blah, blah, blah. And yeah, so we did that 10 times, multiplied by 2 10 times to get that. We could also use a loop. So if you go back to episode 1, we talked very briefly about loops, but enough to get us through this. So in a loop, I would say x is equal, I should have said 1, and then it goes 10 times and I get 1024. Okay, use math.log. We saw that defaults to the natural log. So let's compute log 2 of 1024, log 10 of 1000 without using these specialized functions that you might find in there that are log 2 for log base 2 or log 10, which are log base 10. So I say math.log, the number I want, and then the base. So 2 multiplied by itself, how many times gives me 1024? That's 10. And 10 multiplied by itself, how many times gives me 1,000? So this is a little bit of storage goofiness here, but that's essentially 3. Okay, so let's check the answers. So 2 to the 10 should give me 1024. It did. 10 to the, that's really 3. To give me 1,000, and it does. Problem 8, you can dedupe with a set. So deduplicate, take out duplicates. So the idea of this problem, in a list, you can have duplicates, in a set you cannot. So if a list is converted to a set, then the duplicates will go away. And then you can turn it back into a set and sort that if you want a sorted list. So I start with a list of words, then I cast that list of words into a set. That gets rid of the duplicates, turn that back into a list so I can then sort it. Problem 9, manipulate a dictionary. So given a dictionary, do some stuff. So print Alice's score, add a new entry for Eve with a score of whatever, delete Bob's. So originally the score, Alice, Bob, Carol, Dave, they have scores, print Alice's score. So to get something from a dictionary, you use the name of the dictionary, which is scores, and then you use its key, which is the thing you look up by, which is Alice, and you get 92. To add a new entry, you just say scores the name of your dictionary, whatever your new key is, and give it a value. So it's as easy as that. There aren't multiple steps of adding the key and then adding the value and whatever. You can just do it in one line. Just say that it equals whatever it equals. Print that out, and we can see that Eve is here on the end. To delete Bob's entry, DEL is for delete, and then whatever entry you want to delete. So delete scores of Bob. And then we print it out to make sure, and sure enough, Bob's gone. Factorial growth. Math factorial grows very fast. At what value of n does math factorial first exceed 1 million? So take a silly wild guess. I'll just say I think it's 10. That gives 3 million, which is too much. But remember factorials, it's that number times the integer 1 less times the integer 1 less down to 1. So 10 factorials, 10 times 9 times 8 times 7 times 6, 4 times 3 times 2 times 1. Okay, so if this is 10 factorial, 9 factorial would be 9 times 8, blah, 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 which is 10 factorial without the 10. I'm starting at 9 instead of 10. So I know without computing it that 9 factorial is going to be this number divided by 10. So knock off a 0, and that will be 362,880, which is less than a million. So the first factorial that exceeds a million has to be 10 factorial. You could also do this with loops. Start with x equals 1, run an infinite loop, and then break out of it when you get the answer. Make sure you break out of it. So the factorial, math factorial of x, if it's less than a million, 1e to the 6, 1 with 6 zeros behind it is a million. So if fact is greater than that, print it out, break. Otherwise, increment x by 1 and run through it again. So it's going to do 1 factorial, 2 factorial, not greater than a million, 3 is not greater than a million, 4, 5, 6, blah, blah, blah. 9 is not, 10 is greater than a million, prints it out, breaks out of the loop, you're done. The nth triangular number is 1 plus 2 plus 3 up through that n. Find the nth triangular number for n equals 1, 10, and 50. Again, from episode 1, we haven't delved into this very carefully yet, but functions, a function is a piece of code that you want to reuse or you want to encapsulate. So you define it, give it a number. I'll call it triangular number. You can call it anything you want, but that makes sense. I take an input of n. Okay. And then we'll just keep adding to it. So t begins with 0 for I in range of 0 up through, again, it's 1 less than this. So this will be 0 up through n. Add the next number to it, return it. Triangular number, if you just add 1, you get 1. That makes sense. If you add 10, 1 plus 2 plus 3 up through 10 will give you 55. You can bust out a calculator if you want to see that. Same with 50. There is a formula for this, which is n times n plus 1 over 2. So that's a lot easier. And you can just Google that, or maybe you know that. Or maybe, if you're watching a channel with the word math in its name. Maybe you know this formula. So it's n times n plus 1 over 2. And do I get the same thing? 1 is, of course, 1. 10 is still 55. 50 is still 1275. So that agrees. So I've done it in 2 ways. Okay, unique characters. So given a string, use the set to find the number of unique characters, ignoring spaces in case. Try it on the string Mathy Python with a space in it and 2 capitals. Can you sort them alphabetically? S is Mathy Python. So I replace, you can see there's a space in this one. I replace the space with an empty string. So that I'll wipe out the spaces. So that's ignoring the spaces, and then make it lowercase. So we're not counting capital M and little m as 2 different ones. Print that out, so the S and the length of it. So Mathy Python, you can see no space, it's all lowercase, and it has 11 characters in it. Then S unique is the set of that. So I want to, when I print it out, I turn that into a list and then sort it, and then the length. Okay, number 13 is dictionary inversion. So we're given a dictionary and we want to flip the keys and the values. This is not as easy as it might seem. Dictionaries are not really built for reverse lookups. You have to do it manually. Right, so we will build a new dictionary that reverses everything. There's a nuance here that if I reverse, then I would get A is Alice, C is Bob, B is Carol, A is Dave, but A already has something in it. It has Alice. I don't want to overwrite that. So because of that, we are going to make the values in our new dictionary a list. In the original grades dictionary, we have 2 A's. We want to flip it, so we'll have A, who got an A, Alice and Dave both. Okay, so we need a list for that. Then C is Bob. I'll also put him in a list to simplify the code a little bit. Bob is a singleton, so technically, it could just put a string there and not bother with the list, but it doesn't hurt to have a list with one element. Same thing with Carol. So how does the code work? Start with my original dictionary. Then I will build up a new dictionary. Grades reverse lookup. Get some line numbers here. Line 3, I'll start this new dictionary. And then we will build that. So how do we build the new dictionary? We go through the original dictionary, and we will step through it by key and then somehow reverse these values. So I say for key in the original grades dot keys. So stepping through Alice, Bob, Carol, Dave. Fill out its value. So for Alice, its value would be A. If value is not in grades reverse lookup, so in other words, if the value is not in this dictionary, then we just add it to the dictionary. So grades reverse lookup of, now we flip the key in the value. So in Alice, in the case where we're looking at Alice, the grades reverse lookup of A is not now Alice, and Alice is within a list. Otherwise, if we already have a list, then we don't want to overwrite that. We want to append to that list. So I would say grades reverse lookup of the value and append to that the key. And that gives me A is Alice and Dave, A, Alice, A, Dave. C was Bob, and B was Carol. Error diagnosis. Each of the following lines raises a specific exception and identify which exception, explain why. and fix it. So x is math square root of -1. I get a math domain error. That occurs when you pass a mathematically invalid input into a function in the math module. The math module does not deal with complex numbers. So if you look it up, you'll see that there's a module called CMath that does. So then I can say CMath square root of -1, print it out, and it prints as 1j. The next error, y is the tuple 1, 2, 3. I try to change the first value. I get a tuple. I get a type error. Tuple object does not support line assignment. That's by design. Tuples are mutable. If I did want to do this, then I could just make this a list. Okay, and now it worked. 1 got replaced with 99. Third one, Z is a dictionary, has A with value of 1. I tried to look up value of B. No dictionary entry exists for B. How do I fix this? I could say Z equals A1. I don't need the is. And I do need a parentheses. Okay, and let's say else print not in dictionary. Not in dictionary. Okay, so we did something like this a couple problems up. Where did they go? Yeah, where I checked for the value in the dictionary, or I said not in the dictionary. Either way, you have to check this if it's in there. Otherwise, you get an error. W is math factorial of 1.5 doesn't work. Gives you a type error because factorials only work on integers. How do we fix this? Let's say x is 1.5 factorial of x. If, let's say, integer of x is the same as x, and let's just print that out. Otherwise, we say it's not an integer. Okay, so it's not an integer. Okay, number 15, the birthday problem. In a group of 23 people, the probability at least 2 share a birthday is just a little over 50%. The exact probability that at least 2 people share a birthday is given by this formula. Computed for n equals 23, then n equals 30 and 50. So yeah, I wrote a function, probability is 1, then I step the range up through n. So this will go 1, 2, 3, up through n minus 1. So then this goes all the way to from 0 to 365 minus quantity n minus 1, which is the same as 365 minus n plus 1. So that checks out. And then I'll return 1 minus that times 100. So it's much easier to compute this part of it, then subtract it from 1 and multiply it by 100 to get a probability, and then I print it out to 1 decimal place. So when n is 23, p is 1, I goes 0 to 22, it multiplies each factor, and then returns the probability. So when n is 23, the probability is 50.7. When it's 30, it's 70.6. When it's 50, it's 97. So that might seem like these probabilities are very high, but it's not the probability that I share a birthday with somebody else in the room. It's the probability that any 2 people in the room share a birthday. So there are a lot more pairs within a group of n people. All right, so I hope those problems were interesting and challenging for you. And yeah, we'll do this again in the next one. Happy programming.